Hello students, today's video is concerned to valence bond theory of complex compound. Well, for studying valence bond theory, we should note the following postulates. The main point of valence bond theory is that to find out the hybridization of the complex compound. Now, this hybridization of the complex compound is a concerned issue for the central metal atom, that is transition metal, which has to be coordinated with the ligands, which will donate a pair of electron to the vacant orbital of the central metal atom. That should be transition in nature, that we have already discussed in the previous videos. Okay, the second point is what the available atomic orbital should be there to make up a hybrid orbital. Available atomic orbital means s, p, d. These are the available atomic orbitals, and that should be there to interact with that of the ligands in accordance to the coordination number. Now, what do you mean by coordination number? Coordination number is the number of atoms, or that number of ligands, associated with the central metal atom. So here it is, the ligands are what? NH3. It is associated with the central metal atom. That is what coordination number. This coordination number is 4. Coordination number is 4 over here. Okay, so similarly, say ZnH2O whole 6 is there, and that is also Cl2, and that coordination number belongs to what? 6. Okay, so this coordination number will decide about the proper hybridization of the complex compound. The proper hybridization of the complex compound can be, if the coordination number is 4, that means it will be sp3, and that will be tetrahedral, or dsp2, that is square planar in nature. On the other hand, if the coordination number is 6, that means it will be octahedral, and octahedral is being differentiated into two parts. That is what? Inner octahedral complex, that is what? This D2sp3, or outer octahedral complex, that is sp3d2. How will you differentiate between inner octahedral and outer octahedral? The inner octahedral and outer octahedral can be differentiated. That is, inner means D starts with D, and outer means ends with D. So the inner octahedral complex and outer octahedral complexes. And remember one very important thing, that ligands will contribute the pair of electron to the central atom all the time in accordance to the coordination number. Okay, so these are the important aspects by which you make a valence bond theory postulates. Now, there is some specific ways by which you can name the which you can find out the hybridization of the complex compound, and these are the specific ways, and depending upon the spectrochemical series of the ligands. Now, spectrochemical series of the ligands is dependent upon, there's a specific ways by which you can remember the spectrochemical series. I have made some tricks for you so that it will become easier for you to remember the whole of spectrochemical series of ligands. This is depending upon the increasing order of crystal splitting. Okay, now this is increasing order of crystal splitting. I will be speaking about crystal splitting in the next video. Okay, when we come across with the next video, I'll discuss about crystal field theory in detail. Now, this is what the ligands are there with increasing order of crystal splitting. That is iodide, iodo, that is bromo, thiocyanato, chloro. Okay, so these are all the names of these particular ligands over here. Okay, hydroxo, oxalato, aqua, thiocyanato. Okay, everything has been said. Now, these ligands differentiation has been divided into two parts. One is a weak field ligand, and the other one is a strong field ligand. Students, you don't have to remember so much. Just remember that cyano and carbonyl are strong field ligand. Okay, and this strong field ligand will always form a low spin complex. And weak field ligands are all the weak field ligands are there. All are the weak field ligands. Okay, and this will form a high spin complex. Remember one thing, that ammonia is very important ligand over here. It will act as a weak field ligand all the time, except in the case of cobalt, it will act as a strong ligand. Only in case of cobalt, it will act as a strong ligand. Okay, only in cobalt it will act as a strong ligand. Remember this one. Only in cobalt it will act as a strong ligand. Okay, only in cobalt it will act as a strong ligand. Apart from that, ammonia will act as a weak ligand all the time. Okay, so we have discussed about this, and I have made some trick by which you can remember the spectrochemical series of ligands. That is, Indian brought some colorful sweets. I for Indian, brought for BR colorful sweets, and I have made some colorful sweets from office containing water. Nani ate 9 in canteen corridor. I have taken all the abbreviations of the first letters and I tried to make this particular trick so that it can be remembered for long. Okay, so how to go for solving VBTs? There are some specific tricks by which you can make the VBT very easy for you. Okay, for this you have to see that, say, CrNH3 whole 4 plus 3. So CrNH3 whole 4 plus 3 is what? Chromium is, you know it very well, that is atomic number is 24, and that is 18, 3d5 and 4s1 is there, and 4s1 is there. So what you should do, first you find out the oxidation state related to it. There is x plus 0 is equal to plus 3, you can take it. That means x will become what? Plus 3. Now chromium is having 24, we have discussed, that is 3d5 and 4s1. 3d5 is there, 4s1 is there. Okay, and 3d5 and 4s1, and is having plus 3 oxidation state. That means plus 3, if you take into consideration, you have to remove out all the 3 electrons from here. So if I remove out all the 3 electrons from here, you see this is what coming up like this way. This is 1 and this is 2 and this is 3 electrons are gone. Okay, are gone. So if I remove out these 3 electrons, this is becoming chromium 3d3. And now, since ammonia is acting as a weak ligand, all the time it will act as a weak ligand. Only in the case of cobalt it will act as a strong ligand. So here it is what? The ligands will participate in the case of bonding formation, and it will donate a pair of electron to the central metal atom, that is chromium, by the means of a coordinate bond. So it will donate a pair of electron 2 to 4 to 6 to 8 to 10 to 12, because this is what? This is an NH3 and this is what? Whole 6. It should be whole 6 over here. So this is what? CrNH3 whole 6 is there, and this will become what? D2sp3, D2sp3, D2sp3. Okay, so this is an inner octahedral complex. Okay, so this is an inner octahedral complex. Why did he say an inner octahedral complex? Because it starts from D, that's why it's called an inner octahedral complex. The compound should be CrNH3 whole 6. Okay, now next question is CONH3 whole 6. Okay, so same thing, you have got plus 3, so x plus 0. Why? Because ammonia is having a 0 oxidation state, that is equal to plus 3, and x will become what? 3 over here. So cobalt is 27 atomic number and it's coming out to be 18 and 3d7 and 4s2. So 3d7 and 4s2, if we take it into consideration, now it has got a plus 3 oxidation state, so it will remove out plus 3 electrons over here. So if I remove out all these 3 electrons over here, sorry, not this one, sorry, this will be removing out this one. So it is removing out the 3 electrons over here. So this is removing out this 1 electrons from here also. So this is becoming, this is the 3d6 now it's coming up to be. Okay, so now ammonia is a strong ligand. So if the ammonia is a strong ligand, so what will happen? It will go for a pairing up of unpaired electrons. So this will go for pairing, this will go for pairing, this will go for pairing. and here it is what coming up to be. There are 6 ammonia ligands over here, and each ammonia will contribute 2 electrons at a time. That means it becomes what, again 12 electrons to be contributed, and it becomes D2sp3, and this is inner octahedral complex again. Similarly, say FeH2O whole 6, Fe is 26, 26 is there, and this is what, again x plus 0 is equal to plus 3, and this is what x is equal to plus 3 is there. So this is what coming out to be 3 electrons have to be removed out, 3 electrons are removed, and this is, now water is not a strong ligand, it will have the weak field ligand over here, so it will not take part in the pairing up of unpaired electron. So here it is what, 6 water are there, 6 water molecules are there, and water ligands are there, and therefore what happens, it will contribute 2 electrons at a time. That becomes sp3d2. It's called outer octahedral complex. Similarly, NiCN whole 4, Cn whole 4 2 minus is there. Okay, so NiCN whole 4 2 minus, it should be NiCN whole 4 2 minus. So this is coming out to be x minus 4 is equal to minus 2. So x becomes what, 2. So here it is what, nickel is 28, and this is 18 3d8 and 4s2. So it has got 2 oxidation state. So you can just remove out these 2 electrons. And here cyanide is a strong ligand. Just now I have told you that cyanide and carbonyl are strong field ligands. So what will happen? This will go for pairing up of unpaired electrons. So it will go for a pairing up of unpaired electron, and this becomes dsp2, and this is called a square planar complex. Okay, similarly we have got all these components which have been used over here. I have done so many questions for you. Please practice from these all questions. It will be quite helpful for you. Okay, and remember, you have this, there are some certain limitations of the valence bond theory, and that valence bond theory involves a number of limitations where you will find it out that it cannot give you a detailed magnetic properties of the compound, of the complex compound, and it cannot give you spectral properties of the complex compound. Does not explain, and at the same time does not explain thermodynamic as well as kinetic stabilities of the different complex compound. Okay, so and its prediction regarding to tetrahedral and square planar is not at all perfect. Okay, so it's very difficult to get you a perfect knowledge of tetrahedral as well as square planar complexes. Students, have tried my level best to give you a perfect knowledge of VBT. The link to the PDF of this video has been given in the description box. Please see to this particular PDF thoroughly, and thank you.